It's time, so let us start. I'm Ryusuke Masaoka with Fujitsu System Integration Laboratories, and I'm a research principal doing CTA research. I'm honored to host this talk by Tobi and Thomas. Tobias Limmer. Okay. Maybe I should go first with Thomas and Thomas Pröll. Tom is working for Siemens in product security for 15 years. After 5 years of penetration testing, he changed sides, and he's now leading the incident handling and vulnerability response team for Siemens ProductCERT. Okay, and Tobias Limmer, Tobi, being involved in the field of security since 20 years ago. Tobi has been focusing on the industrial side of IT infrastructure for over 10 years now, starting with vulnerability handling. In Siemens ProductCERT, he was very involved into the automation of security tests, right? And now one of his research area is tool-based vulnerability management and risk-based mitigation decisions. And he likes French comics. It says so here. Okay, so the title of the talk is CSAF, the magic potion for vulnerability handling in industrial environments. So the floor is yours. Thank you.
Thank you. Thanks for the introduction. So CSAF, that's an abbreviation for the Common Security Advisory Format. Is the audio okay? Yeah, okay. Common Security Advisory Format. And why we think this is the magic potion of vulnerability handling, I will describe in the next few slides. Okay, we are talking about industrial environments, and we just heard the talk about TEPCO. They are special industrial environments. They are not the office environments that you guys might know every day. They differ in many, many different aspects. And it's hard to give a general overview over that because hospitals look completely different than oil rigs that we see here. And they look different to water treatment plants or whatnot. But they have some things in common. So, for example, they used to be air-gapped. Air-gap means we do not have any connection to the internet. I heard this so many times from people running those plants. They told me, no connection, no cable, nothing. That could have been true 20 years ago. But in the meantime, we realized that they want to have remote service. They want to have data exchange with IT, for example, for tax reasons. So how many products did you deliver in the last month or so? They need to give their actual numbers to IT, to order, to process, to pay taxes. And this is why they pulled cables between OT and IT, put a firewall there, concentrated on the perimeter, and all was good, you could think. However, they want to have, or they are on the way to further improve, to further integrate. But there are some obstacles. For example, the long hardware life. We heard from TEPCO 30 years for some devices. That's quite common in oil and gas. That's quite common also in hospitals. You have huge investments for those devices, and you don't throw them out after a few years. You also have no online updates, and you have no central management, like Active Directory or so. It's very rare to find in those environments. So the integrated security, I have to cross out, unfortunately. So this does not work today, at least. And today, these people are still bound to manual patching and manual management. So there are still many USB drives going in and out of those factories, many Excel sheets with assets going forth and back. There's very few automation there. Let's see how this works in IT. And there are my role models. In IT, I put here 3 big vendors. This is Cisco, Microsoft, and Oracle. And I evaluated how many CVEs they published per year. And you see that this grew over the last 20 years. So when you look at Cisco, for example, they started with around 50 vulnerabilities per year in 2002. And they are around 600 vulnerabilities per year today. Microsoft also had a huge growth. They started from 100 and up on 1,000 over 20 years. And same with Oracle, and same with basically every professional big software company out there. And these are my role models. So when I'm in Siemens ProductCERT, when I think where would I be in 5 years, I say I want to be there with 1,000 vulnerabilities found, fixed, and published. That would be awesome. Because currently in OT, it looks like that. It's not the same scale. You see on that side, Siemens, we ramped up like everybody does. We ramped up from around 50 vulnerabilities a year until 300 in 10 years. And the others follow. You see the trend, like in the IT world, it goes up. However, the OT world is basically approximately 10 years behind the IT. The question is, will this manual approach that currently takes place in the industry, this manual patching, this manual configuration management, etc., will this prevail in future? And I have my doubts. So no matter which metric I use, I have two different here. Manual processing of advisories will probably not scale. Probably does not scale today even, but if you look into the future, it will not prevail in the future. This is an important slide. You will see this slide growing over our presentation, and this is why I take some time to explain it. What you see here on the left side are the advisory creators. That could be Siemens, that could be any other vendor who writes security advisories. And he has some tools, and there's a certain outcome in the quality of the advisories. And on the right side of the screen, you see the advisory consumers. They also have to do something with the advisory that are created. And now let's look at the first level of maturity that we have. We created our first advisories with Microsoft Word. So really an Office application as the tool of choice. And yeah, we write, "Dear sir, we have a vulnerability in this product." And then what came out was a human-readable advisory, which has a nice logo, and it's a document, and we could distribute it. And that was really the first step of vulnerability handling. And the people consuming those advisories, all they needed was a web browser, coming to our website, coming to a different website, finding our advisory and reading it and manually acting upon it. This step sounds trivial, but in reality, we see some companies who, on both sides, some people who should create advisories and they don't, And we also see some people who should read advisories, and they don't. So the first step, as trivial as it seems, is a challenge for quite some. And this is a challenge that we took for around 10 years now. But we really got to the next step. We finally set up a content management systems where we have products in a database and vulnerabilities in a database, and then we connect them and say this product is affected by that vulnerability, and this could now be generated into a JSON, a machine-readable advisory format. So now we have not some random structure, some random data in a Word file, but really structured data that can be parsed and structurally read by a machine. And with these machine-readable advisories on the creator side, there is action needed on the consumer side, because it does not make sense when we make those machine-readable advisories and nobody reads it. So for the consumers, it will go into ramping up their automation as well. And how we do this will be the part of Tobi, whom I pass the pointer.
Yeah. So I will just skip back to the previous slide here. So if you look at all of that, so I mean, you could ask yourself, so in IT, it worked over the last 20 years quite well. Why do we need something different in OT? So if you look at also the typical OT environments, you do not have central management. You do not have the typical online updates. If you look at the typical standard operating systems, you have everything included. It's easy to update. And this is what we don't have within OT. And as Tom already said, so we have asset management in OT, but usually it's also a manual process. We've got typical Excel spreadsheets, and that's very common actually inside the typical industrial environments. So it's hard for our customers actually to digest the information, to digest all the different vulnerability information and take action on it. And that's a problem in OT. And it's not only one vendor, it's not only us, it's many other vendors as well that are integrated within one single environment actually. And this is a problem for many customers. And this is why we were looking for a way actually, how can we automate that and how can we design that as openly as possible. So, and for us, actually, CSAF, the Common Security Advisory Format, is the solution for all of that. And OASIS has a technical committee who is standardizing that. At the moment, we're at the committee specification, so it's a standard that is readily available that you can use already. And that's nice, actually. Everything is open source, everything is available, and everybody can really digest the data that we've got here. So you can see the GitHub repo link at the bottom. You can even see all the discussions that we have inside the working group. So everything is open here and also ready to use. So how does it look like? So I will just give you a brief example of how we are doing it on our website. So if you go to Siemens ProductCERT advisories, you will see the list of advisories that we already published. And now it changed a little bit because we put in a new link here called CSAF. And here really you have a machine-readable version of all of our advisories. Actually, we have a link here, but that's more for marketing because usually you want to use scripts to download all of that. Everything is really contained in the standard, how you do that, how all of that is really automatable. So in the end, you should not need to use that link here. You should really use scripts to download everything here. How does it look like? So one example is shown here of one of the advisories. So if you click on PDF or HTML, you will exactly see that document here with the typical information that you know from typical security advisories. So we've got our title, publication date. We've got a short summary of one of that document with one or multiple vulnerabilities, and then quite important here, all the affected products and versions. With corresponding remediation. And here you can see actually the problem we've been talking about. all of that is free text. Still, we do not use Office applications anymore for that, so it's an automated system in the background, but still it's free text that you've got here. And this needs to change actually, because if we have free text, how also the different products are named and the versioning scheme are being used, so that's not automatable, so rather hard to process actually, and this is a problem. So how does it look like now with CSAF? So just a quick overview. So it's JSON-based, and essentially all the information that you have in the advisory, you can also see here within the different JSON fields. So here you've got the title again, you've got also the publisher, you've got the distribution, how the TLP labeling is actually, and usually we have as TLP labeling white, because everything is publicly available that we publish on our website, of course. Here we have actually one policy within Siemens that in cases of products where we do not know all users of, so, and this is usually for typical products you can also buy on Amazon or wherever, there we publish the vulnerability information. And we have one exception: if we know all the customers, and we've got certain sectors where we actually know all the customers, for example for trains, there we don't need to publish that online, and usually we don't. And this is why you usually only see also advisories from the typical products that are free on the market that you can also buy yourself. Further on, we've got tracking IDs inside. We've also got the revision history, all of that nicely standardized. If you look at single vulnerabilities inside the JSON format, you can see also CVE. So for those who do not know CVE, it's the common vulnerability enumeration. It's a unique ID for each and every vulnerability that is being assigned, so globally unique. So it's very nice, so if you want to correlate information also from different sources. And then we've got certain nodes here, for example, a summary of the vulnerability. Then we've got also CWE, which is the common weakness enumeration, which describes actually the type of the vulnerability itself. Here it seems to be some kind of improper input validation inside the code that causes the vulnerability itself. And then also very important here is the products. So, and here this section here shows you what kind of products are affected, and it just references other sections of the document. And down here, we also have the CVEs score in the current version here, 3.1, depicting the severity of the vulnerability. So it goes from 0 to 10, and here we've got a base score of 7.4, which is quite critical actually. So looking at the known affected products, there's another section inside the document that tells you exactly, okay, what kind of product is actually affected here. And here, for example, we've got a scale length, I think it's an access point, and all firmware versions of version 3.00 and lower are actually affected of that vulnerability. Furthermore, you also have additional identification helpers, so certain criteria where you could actually identify the products themselves in a simpler way. I will go into more detail about that later. So in the end, we're considering all of that our magic potion. So we like that a lot. Everything is freely available. We can publish all of that. It's easily interpretable. All interested people, all interested parties are able to read that. That's good. So it's essentially what you want to have. So public advisories. We want to also enable the collection, the redistribution, and extension of those advisories. So we know of certain communities and also parties actually collecting different advisories from different vendors. So for example, we've got CISA in the US, we've got the BSI, the Federal Office of Information Security, who are collecting the advisories and also redistribute the advisories to certain users, also in the OT realm. And in the end, the goal should be that sharing is being fostered. At the moment, we just have our single documents, and we really want to enable people, the whole security community to do sharing and essentially do the typical threat intelligence way of communicating and providing information. So at the moment, there are a few open source tools available. The standard is quite new in its current version of 2.0. And it's mainly concentrating on the publication of advisories. So it helps actually us, the vendors, to create those advisories in the CSAF format. More tools are in the pipeline, so also supporting consumers, so actually people who operate equipment, companies who operate equipment and want to know, okay, am I affected or not of a certain vulnerability? But it's still in the flow, so we are starting to work on that, but it will still take a little bit of time.
Are you aware that they published it last week, 10 new tools around?
I was not aware, actually.
So even for consumers.
Okay,
yes.
Good to know. Thank you. So a lot of activities happening in that community, and we really appreciate that. So if you want to know more, actually there's a tutorial happening, I think, right now by the Federal Office of Information Security here at FIRST. So you're too late if you want to know more, but I hope they're gonna redo that tutorial in the future as well. So going on. So now we've got our CSAF format, but I would rather say it's just a start. So we need to get better here. And one of the big problems that we have here now, so taking the next step on the maturity ladder, unique product identifiers. So it's the essential problem is usually on the one side you've got your asset list as an operator of equipment. On the other side, you've got those advisories, and you need to match those. And what you need to have here is some kind of product identifiers where you can really match both entries from those two lists. And this is not easy to do. Not easy to do at all. And we started working on that. If you go back to the previous slide, you saw we are using an order number actually to give a unique identifier, at least for our own devices. But we know it's not enough. So, so we created that, and also the CSAF format created that to be extensible. So we can use different unique product identifiers for this matching process. And a lot of discussion is already being done in the security community, inside the product security community, about that problem. So there are very many standards available, SPD-X, we've got SBOM with Cyclone-DX, and so on and so forth. And it's being discussed what's the best way. But in the end, our opinion here is, usually you do not agree on one single standard, so we will try to support as many as needed, actually. So what we get there then is input for automated asset management. So you can automatically match those two lists, asset lists and the vulnerability lists. That's good. And then you can also do on the consumer side, so the typical operators of the environments, they can do that automated advisory processing, which is great actually, because they do not need to do that manually anymore. And I'm emphasizing that because I'm not talking about IT side, I'm talking about industrial environments. And we know that a lot of customers of us, typical industrial operators, have that problem. And this would be solved then, actually. And in the end, we want to have a complete asset management process on the operator side. So identifying products, I already told you, it's kind of a big problem. So if you thought that maybe CPE, the Common Platform Enumeration, which has been around, I don't know, for quite some time, 10 years longer, it already tried to solve that problem for us. But unfortunately, at least for us, it's not a working solution because, so here, it's very small. I just looked for a typical product of us, so that's the S7-1500, so a typical controller for industrial environments. And if you look that up, you can see a lot of entries here. Here it's different versions actually, but it's also different naming schemes. On the one side, it's the order number that is being displayed suddenly in here. On the other side, it's called SIMATIC S7-1500. Then in some cases, we've got SIMATIC S7-1518, which is a special model of the S7-1500. And it's not working. So you've got really duplicates inside CPE, and this makes it actually for us useless, unfortunately. And this is why we need to solve the problem in a different way. And as already said, currently we're using order IDs from us, but we can use any other ID as needed later on. And the nice thing is about those order IDs, if you ask our devices with SNMP, they will tell you the order ID. So automated matching becomes possible here. And this is actually our first step on the way here. Now, a little outlook also into the area of SBOM. So how does all of that work together? So on the one side, we've got CSAF with a lot of information about the vulnerabilities, a lot of details, the necessary details about single vulnerabilities. On the other side, we've got SBOM, so the software bill of materials, that gives you a lot of insight into the systems themselves. So for example, if you have an embedded controller, the system, it consists of one or multiple applications on the inside. It will consist of one or multiple libraries. It will consist of maybe certain modules in the background as well. And SBOM gives you really insight into all of that. That's good. But in the end, it's a lot of data that is available. And on the other side, we're coping about single vulnerabilities. And the nice aspect here is that a new standard is being worked on that's called VEX, Vulnerability Exchange. And this is actually a very short advisory containing not a lot of details. It's just about a vendor statement. So is a certain product affected or is it not affected? And this bridges the gap actually between those two different worlds. On the one side, SBOM with a lot of information about different components, where, for example, a certain, let's say, OpenSSL vulnerability is indicated, and VEX then enables the vendors to quickly issue a statement, are we affected in certain products or not? And for VEX, actually, there's also a CSAF profile available where we can just publish that necessary information inside CSAF so that we don't need to jump on a different format. Right, so that's about unique product identifiers and SBOM. How will it go on? Next step would be really not only from time to time issuing the advisories. At the moment, we've got our advisory day each month. We expect that to happen more often, especially with highly critical vulnerabilities. We also have out-of-band publications. And what we also need actually in regards to the quality of the advisory is more machine-readable information about details of a certain vulnerability. So for example, what port is affected of the device? Maybe what network interfaces are affected of a certain device if it has multiple network interfaces. Or also what configuration setting is actually needed so that a certain vulnerability is exploitable. One example, the web server of one of our controllers. So if that one is affected, you can easily disable that web server. We would like to see that information inside the advisories as well. And also in an automatable way, so processable way, so that it can be easily evaluated, because we see a lot of information actually being pulled out of the vendors. As Tom was showing within the statistics, it's going to be a lot of data that is going to be published also in the years to come. So we need automation for all of that. And this enables consumers to more quickly decide, am I affected or not? Because they can decide, that's the web server, but it's protected by my perimeter. So it's usually no problem for me, for example. And then we also see automated patching. So big issue in OT environments. We do not have central management. It's usually footwork for the admins to patch a PLC. Guess how often it happens? Almost never that any embedded device in industrial environments are actually patched. And in the end, it would be good to design the whole system so that also downtime of single systems are accepted and can be mitigated. But that's going to be a challenge, especially for the OT environment where we have long lifetimes, a lot of equipment in brownfield that are old, that won't support new standards, aspects like that. And we need to cope with all of that. So that's only partly applicable to OT. I was also writing here because of automated patching. At the moment, we don't see it, but maybe in 15 years, let's see how it will develop. So thanks for your attention. Thanks for the interest here.
Thank you very much for a very interesting talk. I was vague about CSAF, VEX, and SBOM. Now I have a clear picture. Thank you. So any questions, please use standing mics there or there. You can have it closer over there.
Hello.
Hi.
Thank you for a very interesting and in-depth submitment. As a customer who has a lot of various Siemens implementations, we often regard it as more risky to actually perform a patch in terms of, will it work if we have to downgrade? Will that even work? What are the experiences from other customers of Siemens that have performed the same? I might think that you would have a protocol so that when you release a patch, you have a method that customers can report back to you whether or not it worked with certain types of integrations, certain types of installation environments, so that you could warn other customers that if you have this and this environment, you might want to watch out for this and this. Some feedback loop for that.
So we have the support, of course, that's available to all the customers. But you are right. That's something that is needed, actually. So I mean, what we know within typical updates. So we get incompatibilities. You will not be 100% sure that it will work after an update, and we are working very hard actually to ensure that. But there will be always corner cases. So. We really have to think about that. So we also have to talk to the product owners here. But I think it's a good suggestion, actually, that there's a feedback loop, also giving warning to customers about certain incompatibilities inside the new software.
Yes, but that has to be automated by Siemens, so that because if it's a critical vulnerability, this might have to happen within hours or days. So if a customer detects something, if we detect something when we install a patch, there should be one simple, easy-to-know channel to get that feedback back to Siemens, and for that information perhaps to flow to other customers as well. That's
what you also do not have right now is an automated way of checking the compatibility, because usually you've got multiple components inside your OT environment, and all of them have to work together. And you also need to have the acceptance actually of the vendor that all of that works together. And if you update now one component, will it still work? Is it still actually approved by the vendor in that specific environment? That's also not available. And we know of that issue, actually, but the feedback loop is a good suggestion.
I noted that you can make future use of identifiers in the JSON. So identifiers that tell you, have you enabled this and that feature, or do you use this and that plugin, could also be used to narrow down further exactly which systems are susceptible to a vulnerability. Even if the product is susceptible, you might not be vulnerable if you have configured it in a certain way.
Right, that's what I was talking about, the configurational aspects, actually. That should also be contained inside the CSAF advisory. We have that already, but it's free text. And we need to standardize that so that you can, that it's machine readable and you can automate.
Asset management is a challenge, but that is an even bigger challenge.
Yeah. So we have this on the roadmap. We know this, and but this is the first step, as we showed with those 4 layers of maturity. This is the first step, that you have something automated, and it will become better. I promise you. And about the feedback channel, currently ProductCERT at Siemens.com is the entity that gives out those advisories. And if you have problems with these advisories, I take it on me that you can use the same channel to get feedback on those advisories and on those patches. So we can forward them to the team. And if we are overwhelmed with the feedback, we need to find a way of how to automate it.
Thank you very much.
One more question?
Yes.
I also.
I worked on CSAF 1 for a bit long ago with Stefan Hagen, and like common product enumeration standard, the CPE. That standard needs a little bit of brush up, it seems like, because we've had a little trouble with it in Stix land, and I was wondering, is CPE still part of CSAF or no?
It's not. No.
Okay, then that was a dumb question.
CPE is not part of CSAF.
CPE.
It does not work for us. But you are working on something that could work in a few years down the
So
line.
would that be a more generic next version of CPE, or would it be really bespoke to the needs of CSAF?
So CSAF is really agnostic to the product identifier. So you can use CPE, you can use order IDs as we were using in the advisories or are using. So it's really agnostic. So whatever comes, it will be usable within CSAF. That's the nice thing. But we do not know yet what will come. So it's a discussion that is ongoing. And in the end, I would expect that it will never decide on one single standard here. So we need to support multiple ones. So
that wasn't my question. My question was more, is there something better than CPE?
not anything globally available.
Yeah.
For us, order IDs are better, but that's Siemens specific. Sorry.
Please.
Okay, I got one last question. My question is about you speeding up until it hits the customer. So you speeding up the producer side, but then how do you envision the customer of your product being faster in patching or doing the countermeasures? Do you have any vision on how that can be supported, speed up, whatever your goal is?
So first off, the receiver is not just the customer. It's also, it could be certs, it could be anyone who needs to read our advisories. So it could be some vulnerability scanner company who makes tests for those vulnerabilities or so. And we are not the only producer, so it's an open standard. There are many other companies who support it currently. For the people who receive it, they need to improve their automation. Depends on the specific use case. A cert has to do something different than an oil company or so. And asset management, for example, to have a database of what are my assets is a very good first step. So you have your assets, you have the vulnerable products, and then you can do the matching between those two. And this should be half automated or full automated, or you have to see how far you get with the first step. We want to improve this in maturity level 3 and 4.
So,
okay, thanks.
In the end, you've got two solutions. On the one side, open source would be great if you get additional tools for the operators. Second is commercial providers. So typical threat intelligence providers of vulnerability scanners. They will, of course, also use that information.
So there are parsers and visualizers, and there's a lot of stuff. I think last week it came out and is on the CSAF OASIS page visible.
One last follow-up question. CSAF is targeted only at OT or also envisioned for IT?
For IT,
everybody.
Okay, thanks.
Sorry, could you make it offline?
Offline, okay.
Okay. So let us thank the speakers again.
Thank you. Thank you.